Okay, greetings to all. This is Dr. M. Shakti Mohan, Associate Professor. So today we are going to discuss about the number system in terms of representation and conversion. So under the playlist of digital electronic circuit, actually there are four type of number systems were there. That is binary, octal, decimal, and hexadecimal. We'll see one by one. Okay, so here you can see the basic table for the number system. That is, since I already told you there are four type of numbers were there. There is decimal, binary, octal, and hexadecimal. The base for each and every number systems were for decimal the base is 10, and for binary the base is 2, and for octal the base is 8, and for hexadecimal the base is 16. Actually, base means how many numbers were there in that number system. That is what the base. That means since decimal have the base of 10, so that means it contains numbers from 0 to 9. Okay. So decimal, so we have a 0 to 9. So the total numbers is 10. So that is why the base for the decimal number system is 10. So likewise, for the binary, we have a base of 2. That is, it contains a numbers only two numbers were there. That is 0 and 1. Okay, so totally two numbers were there. So that is where the base of binary number is 2. And for the octal is 8. So that means it contains numbers from 0 to 7. Okay, so 0 to 7 means you know that. So the total number is 8 numbers. And for the hexadecimal, we have a total number of 0 to 15 numbers were there. So the total number is 16. Okay. So those are the bases for the numbers. Okay. So totally there are four different type of numbers were there. So the base for the numbers is a decimal 10 and binary 2 and octal 8 and hexadecimal 16. Right. So this is the general table for the binary number systems. That is decimal, we have a numbers from 0 to 9, and after 9 with the help of the above 0 to 9 we will make the numbers. That is after 9 we don't have a numbers, so 1 and 0 will be combined for 10 and 1 and 1 will be combined for 11. So likewise up to 15 we will write, right? And for binary we have only two numbers, right? So that is either it may be 0 or it may be 1, right? So only two numbers were there. With the help of those two numbers we are going to represent the number. So here I'm just to write the binary numbers for 4 bit. Since it is a 4 bit, with the help of 8421 combination I'm going to write the number. Okay, so how to write the numbers in binary now? With the help of 8421. That is for 0 in the 8421. Okay, you can see, let me write it here, 8421. Okay, so for 0 there is no 0 in the 8421, so that is why all the numbers were 0. And for the 1 there is a 1 in the 8421, so for that 1 alone we have to put 1, and for the remaining numbers and all 0, right? And for 2 there is a 2 in the binary numbers, uh, there is a 2 in the 8421 concept. So for the 2 alone we will put 1, and for the remaining and all 0, right? So the next is 3. Actually there is no 3 in the 8421, but there is a way to make it 3, right? So that is 2 plus 1 is equal to 3. So that is why here I'm just mentioning 1 and 1. That is 2 plus 1 is equal to 3. So 0 0 1 1 means 3, right? So likewise you have to write the numbers. Okay, so there is a shortcut also to write the numbers for binary. So what is the shortcut now? For the first digit, that is we can take it as the first one is A, second one is B, and third one is C, and the fourth one is D, right? If we take it like that now, so for the A digit we have to put vertically we have to put 8 zeros and 8 1. Okay, so likewise for the B digit we have to put 4 zeros, 4 1, 4 0, 4 1, right? Okay, so likewise for 2, double 0 double 1 double 0 double 1 double 0 double 1 double 0 double 1, right? Likewise for 1, single 0 single 1. So likewise you have to mention it, right? So this is what the binary numbers, right? Okay, so next for the octal numbers, since we have octal numbers we have only 0 to 7, right? So 0 to 7. So from 0 to 7 we have a regular number. So after 7 we don't have a numbers in the octal. So that is why with the help of the previous number we will make the next number. So that is why 1 and 0 will be there after 7. Okay, so actually in the octal number there is no 8 and 9. So why there is no 8 and 9 means because octal having numbers only from 0 to 7. Okay, that is the reason. So after 7, from 10 to 17 the numbers will be there. Okay, so likewise only the octal number will be there. Okay, and the last type of number system is hexadecimal number. So it contains numbers from 0 to 15, but in that there is some small condition. So what is the condition now? 0 to 9 actual numbers will be there, and after 9 alphabets will be there. That is for 10 க்கு A, and for 10 க்கு A, and for 11 க்கு B, and 12 க்கு C, and 13 for D, and 14 for E, and 15 for F, right? So likewise we have to mentioning the numbers, right? Okay, so this is what the number representation, right? So generally four type of numbers were there, that is decimal, binary, octal, and hexadecimal. So these are the actual table, right? Okay, next we are going to discuss about the representation of numbers, right? So how we are going to represent the decimal number, binary number, octal number, and hexadecimal number, right? So it is very very simple only. So first we are going to discuss about the decimal number system. So let me take a number 5678.9. Okay, so for each and every number you have to mention with the help of the bases, right? So you can see here I'm just representing the number, right? So for the 5 into 10 power 3, because this is 10 power 0, 8 is a 10 power 0, and 7 is a 10 power 1, and 6 is a 10 power 2, and 5 is a 10 power 3. So likewise we have to mention like 5 into 10 power 3, 6 into 10 power 2, 7 into 10 power 1, and 8 into 10 power 9. And after the point it is 10 power minus 1. Okay, so likewise we have to mention. So likewise for each and every number we have to mention it. Okay, since it is a decimal number we have to mention it with the help of base of 10. Likewise for binary the mentioning will be base of 2, and for octal the mentioning will be in the base of 8, and for the hexadecimal, yeah, you are right, the mentioning in terms of 16, right? So that is what the binary hexadecimal, decimal, octal number representation, right? Okay, so next we are going to discuss about the conversion of numbers, that is one kind of numbers from another kind of number. Okay, so it is also very simple. Okay, first we are going to discuss about the binary to octal numbers, how to convert the binary numbers to octal number, right? So very simple one. Actually, binary to octal and binary to hexadecimal having the same procedure. Okay, so we'll see one by one. So first, here you can see the problem is the 10101101 dot 0 111. So this is what the binary number. So we are going to convert this binary number into octal, right? So in case if you want to convert the binary number into octal means you have to convert the given binary number into split of three digits number. Okay, it is very very simple. So the split you have to mention from the LSB. Okay, so I hope you know what is MSB and what is LSB, right? So MSB means most significant digit and LSB means least significant bit. Okay, so how to remember where the MSB and where the LSB means? It is very simple. So always the LSB is situated near to the point. Okay, so for example 583.24. Okay, so if you taken this number now, so here the MSB is this, 5 is the MSB bit and 3 is the LSB bit. Okay, this is for the full number. And in case if it is a pointed number now, it is straight opposite to the full number, right? So here you can see this is what your LSB and this is what your MSB. Okay, for full number, left hand side MSB will be there and right hand side LSB will be there. And for the pointed number, left hand side LSB number will be there and right hand side MSB number will be there. So for the remembrance purpose, it is very easy to remember. That is near to the point the LSB number will be there. Okay, so the students, you have to remember like this. Okay, so you can see from this is what the point. This is what LSB for the full number. This is what the LSB for pointed number. So from the LSB, we have to split the number into 3. See here like this and like this, and one more digit is required, so you have to mention 0. Okay, so likewise this side also, so here and 2 digit is required, so likewise we have to mention. Okay, so after splitting the number with the help of 4 to 1 concept, actually if 3 number is there means it's a 3-bit number, right? So 3-bit means 4 to 1 concept. With the help of 4 to 1 concept, we have to mention the actual number. It is very easy. You can see 0 1 0 means what? 2, right? So this is 2, and 101 means 4 plus 1 5. Okay, so 5, and this is also 5.34. So the answer is 255.34, right? So this is how you have to convert the binary number into octal number. Okay, so now the next one, how to convert the binary to hexadecimal. So the same procedure, in the binary to octal conversion, we are going to split the number into 3333, right? So likewise, in the binary to hexadecimal, we have to split the numbers into 4 digits, right? So again, the same concept. From LSB, you have to split the number into 4 digits. So here you can see, this is what the example, right? So 4 digits are, we have to convert it, and after convert it, since it is a 4-bit number, so 8421 combination we will mentioning the actual number. So the answer for this is 36E dot 9A. Actually, why the E and A will be there now? Since it is very easy, you can see here 1110. So that means 1110 means what is the actual number? 8421. That is 8 plus 4 12, 12 plus 2 14, right? So 14 the actual hexadecimal number is E. Likewise, you have to mention, right? So this is how we have to convert the binary to octal and binary to hexadecimal. So next, octal to binary and hexadecimal to binary. So it is simply straight opposite to the above conversions. Okay, so you can see 125.62. Okay, well, so that means you have to split the number, that is 1, 2 and 5. Okay, so for 1 with the help of 4 to 1 concept, we have to mention the number, that is 0 0 1. And for 2 what is the concept? 0 1 0. And for 5 1 0 1. So likewise you have to mention. Okay, and after mentioning, so we have to combine the number. So this is what the answer, right? Okay, so next, hexadecimal to binary means same concept but with the help of 8421 combination, right? So 8 means what is the 8421 combination number? 1 0 0 0. So 1 0 0 0. Likewise for A, what is the combination? Actually A means 10. Okay, so 10 what is the 8421 combination? 1 0 1 0. So see here, so likewise we have to complete the sum, right? So this is how we have to convert the octal or hexadecimal to binary numbers, right? So next, octal to hexadecimal. Okay, so this is a kind of little bit difficult compared to the previous one. So how to convert the octal to hexadecimal? Simple. First you have to convert the octal number into binary, that is first octal to binary. So how to convert octal to binary? So first you have to split the numbers, and with the help of 4 to 1 combination, you have to mention the binary numbers. So if you mention the binary numbers now, you can get the binary number, right? So octal to binary conversion is the first step, and the second step is binary to hexadecimal. So how to convert the binary to hexadecimal? You have to split the binary number into 4 digits, and after that, with the help of 8421 combination, you have to mention the number. See here, this is what the example, right? Okay, so we'll go for the next sum. So the next sum is decimal to binary conversion. So it is also very easy. See here, they just mention 198.323 is the number. So for the decimal to binary conversion, we have to follow one rule. For the full number, we have to divide the number by base of 2. So why base of 2 means? Because we need the binary number. So the base for the binary number is 2. Okay, so that is why here you can see I am just to divide the number with the base of 2. And while dividing, if there is no remaining, now you have to mention 0 like this, and if the remaining is there, now you have to mention 1 like this, okay. And after completing, you have to write the number, okay. So but don't forget, here only we have to mention the MSB, here only LSB will be there. So that means how to mention the number now: 1 0 0 0 1 1 0. Likewise you have to mention, that is, from bottom to top you have to write the number. That is the concept, right? Okay, so this is for the full number. If it is a pointed number means, so for the full number we will divide the number with 2, right? So that means for the pointed number, what will be there? Yeah, you are right, we have to multiply with 2, right? So after multiplying, so there is a number here. So those are the binary numbers, okay. Okay, so here we have to write the numbers from top to bottom, right? So that is the concept. So this is how we have to convert the decimal to binary numbers. And decimal to octal and decimal to hexadecimal means same process, but decimal to octal means we have to divide the number with 8, because the base for the octal is 8, and for decimal to hexadecimal means we have to divide the number with a base of 16, because the hexadecimal base is 16, right? So the same procedure only. Okay, so the last method for the conversion is a binary to decimal conversion. So binary to decimal conversion is very simple. So since we have numbers, that is 101111.1101. Okay, so as you know, near to the point it is 2 power minus 1. Okay, so 2 power minus 1, 2 power minus 2, 2 power minus 3, 2 power minus 4. Okay, so likewise, after the point, it is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, right? Okay, so likewise, we have to make a multiplication. You can see, so 1. Okay, so this 1 is equal to 1 into 2 power 0 is equal to 1. So likewise, for the next one, 1 into 2 power 2 is equal to 2. And for the next one, 1 into 2 power 2 is equal to 4. And for the next one, 1 into 2 power 3, that is 8. And for the next one, it is no need to for calculation, because 0, so 0 into any number is equal to 0, and the last number is 1 into 2 power 5 is equal to 32. So the total combination is 47. So 47 is the decimal number for the full number, okay. And for the pointed number, you have to make a multiplication of 2 power minus, right? So for that, the answer is 0.8125. So the final answer is 47.8125. So likewise, you have to calculate for the binary to decimal conversion. In case octal to decimal conversion means we have to make the multiplication of 8 power 0, because the base of octal is 8. So likewise, for hexadecimal to decimal conversion, we have to make a multiplication of 16 power 0 1 2, like so, right? Because the base for the hexadecimal is 16, right? So this is how we have to complete, we have to convert the numbers from one radix to another radix, right? I hope you like this content. For today's class, we have discussed about the types of numbers, that is decimal, binary, octal, and hexadecimal. And after that, we'll discuss about one radix of numbers from another radix of number. Thank you.